Welcome to lesson 3 on unit 4. This is all about graphing exponential functions. So we're going to start with our most basic one, y is equal to b to the x. Let's fill in this table. We'll do the first one together. Y equals 2 to the x, so that means I'm plugging negative 3 in for x. That's going to be 2 to the negative 3. Just a reminder that this is really 1 over 2 to the 3, right? If we have a negative, we can bring it down. And this is really going to be 1/8. What I'm going to have you guys do is pause the video, fill in the rest of the table on your own, and then go ahead and plot these points on the graph. So at this point, your graph should look something like this. This is what our basic exponential function does look like. Please go ahead and move on to exercise number 2 and do the same thing. I'd like you to plug in these values. I'll do the first one with you. So this is going to be 1/2 to the negative 3. Well, because this is an exponent, we can actually bring our negative exponent, we can actually bring that 1/2 up and flip it. And by doing that, we now have a positive exponent. This is really 8. So go ahead and pause this and fill in the rest of the table and then graph it. So your graph for exercise 2 should look something like this. And if we notice, we can see that it was definitely flipped. And it was flipped over the y-axis. Now, let's take a look at these two functions and let's think about why it was flipped. This one's 2 to the x. This one's 1/2 to the x. Doesn't look like anything was negated. Doesn't look like anything should be flipped. However, if we take a look at y equals 1/2 to the x, because that 1/2 is a fraction, I can actually rewrite that 1/2 as 2 to the negative 1. By flipping it, I can make that exponent negative. And now it's y equals 2 to the negative 1 to the x, we know that we can multiply the powers and get negative x. Well, going back to geometry, anytime the x is negated, that's really a reflection in the y-axis. So a reflection in the y-axis means that the x is negated, and we can see that's clearly happening here. So now exercise 3 is asking us to look at our graphs from 1 and 2 and state the domain and range. Well, remember, the domain is all of our x values, and on both of these graphs, the x values are going from negative infinity and going further and further to the right towards positive infinity. So it's actually all x values. Our range, however, we notice the y values never go below that x-axis, which means our y values are never going to be negative. They are constantly going to be greater than 0. They won't be equal to 0, but they're going to be greater than 0. So let's go ahead and write that down. So for the domain, I have negative infinity to infinity, or we can state all reals. For the range, I have my little squiggle, and I'm saying y such that, so that line means such that, y is greater than 0, so that's one way of writing it. Or we could simply say it's going from 0 to infinity. And notice there are open parentheses. We're not touching 0, we're not touching infinity, it's just between them. Exercise 4, are exponential functions 1 to 1? How can we tell? Well, remember, 1 to 1 means that they not only pass the vertical line test, but they pass the horizontal line test too. And we can clearly see from this that it does pass horizontal line test. So I'm going to write that in. For exercise 5, we now have 7 times 3 to the x. So it's been changed a little bit. Before we were just dealing with 2 to the x, and now we have a coefficient in front, 7 times 3 to the x. In order to find the y-intercept, remember, the y-intercept is simply setting x equal to 0. So when we set x equal to 0, this is going to be 7 times 3 to the 0. We know anything to the 0 power is just 1, so it's 7 times 1, which is 7. Does the exponential function increase or decrease? Well, because that base is greater than 1, it's a 3, we know that it's going to be increasing. It's going to look very similar to that first function that we graphed. Let's take a look at that. Okay, so we've gone ahead and graphed that function. We know the y-intercept is at 7, and because this base of 3, because the base of 3 is greater than 1, we know it's going to be increasing, just like our first. And part C is sketching our function with our y-intercept. Now, number 6, notice our base is not greater than 1. It's actually between 0 and 1. It's that fraction. And that's an automatic, should tell us that the graph is going to be reflected over the y-axis, just like it was in exercise 2. So for part A, how does this function's graph compare to that of 1/3 to the x? Well, one thing I'm noticing is that this +4 is on the outside. Because that +4 is on the outside, it's not affecting the x coordinates, it's affecting the y coordinates. It's not attached to the x, it's attached to the function as a whole, which means it's affecting the y coordinate. So it's going to be shifting up 4. This is a shift up 4. In order to get the y-intercept, once again, we're going to set x equal to 0. So this is going to be 1/3 to the 0 plus 4. Well, 1/3 to the 0 is just 1. Remember, anything to the 0 power is 1. 1 plus 4 is 5. So our y-intercept is going to be 5. And then part C wants us to create a sketch. Well, once again, because our base is less than 1, and I should say less than 1 between 0, then it's going to be a reflection. I'm going to say this is 5, and our graph will look something like this. Okay, and I did go ahead and write that on the side because the base is between 0 and 1, the graph is reflected over the y-axis.